Hi, I'm Craig the geologist. Welcome to class. Now, if I were to ask you right now to tell me the difference between a rock and a mineral, could you? Or how about the difference between a mineral and a crystal? If I asked you to tell me the difference between a rock and a stone, what would your answer be? Well, there are a lot of terms thrown around in rock hounding and geology in general that a lot of people don't have a firm grasp of. We have a rough understanding of what they are. But when you're asked to really break down exactly what it is, most people just don't know. You will know in a few minutes here. So let's go through what some of these terms mean. Let's begin with some of the broader terms. How about rock, boulder, pebble, cobble? These are all words that mean the same thing roughly, but there are differences. So let's begin with a rock. A rock is a naturally occurring solid clump of minerals, basically. Don't worry about what a mineral is. We'll talk about that in a few minutes. Stone. A stone is a rock. That's all there is to it. Now, a lot of you are thinking, no, there's a difference. I'm sure there's a difference. I know a lot of you are thinking that because I've seen the arguments online. All right. I've seen people arguing that a stone is a polished rock or that a stone has to have a certain look to it. No. Rock is stone. It's the English language. There's more than one word for absolutely everything. And this is another example of that. Rock equals stone. All right. So if anyone starts arguing about whether this is a rock or a stone, you know they're being silly. All right. They're the same thing. Now, there are differences in the words we use based on the size of the rock or stone. So, for example, boulder is a very, very large rock. It's defined as being a rock larger than about 10 inches. I thought about bringing a boulder here to show you, and I just don't have that much energy. I'm going to ask you to use your imagination. But my forearm here is almost exactly a foot from wrist to elbow. And yours is probably a similar size. As a species, we're all pretty similar in that regard. So a boulder is anything about the size of your forearm or larger. Less technically, a boulder is anything that will make you scream if it fell on your foot. All right. Cobble is the next size down. Cobbles are roughly hand-sized rocks. All right. That's the easy way to remember it. They are rocks from about 10 inches, about the size of the small end of a boulder, down to about 2.5 inches. So cobble-sized rock right here. This might also be a cobble-sized rock. We go down from that, we get into the realm of pebbles. Now, pebbles are 2.5 inches down to the size of sand. All right. And then you get a whole range of sand sizes. We're not going to go into that. There's coarse, very coarse, medium, fine. Then you go into silts and clays. That's a whole sedimentary geology lesson that we're not doing today. All right. But pebbles are rocks that are a couple of inches in diameter down to very large sand. And the difference between pebbles and gravel is that gravel is jagged. All right. So mechanically broken. Pebbles are rounded. All right. So you find pebbles in a stream. They're smooth. They don't hurt very much to walk on. Gravel, if you're in bare feet, it's going to hurt. All right. You're getting poked. No one likes walking on gravel in bare feet. That's the only difference between pebble and gravel. Pebbles are 2.5 inches down to coarse grain size, and they are smooth and rounded. Gravel is 2.5 inches down to coarse grain size, but they hurt to walk on. They are jagged. They're mechanically broken. All right. So those are the differences there. Now let's talk about what a mineral is. This is to get a little bit more scientific, get a little more in depth. All right. A mineral is classified as a naturally occurring solid substance, and it has to have a pretty well-defined chemical composition. And we're using pretty well-defined loosely because there are what I call trash can minerals that you can just throw the whole kitchen sink right into that chemical formula. They've just got everything on the periodic table hanging out in there. But they do have to have somewhat of a well-defined chemical composition. have to be naturally occurring, and they have to be solid at standard temperatures, standard temperature and pressure. So a rock is a naturally occurring mixture of minerals. Has to be solid, has to be naturally occurring. Is asphalt, concrete, sidewalk, is that a rock? If you chunk it up, is that a rock? No, because it's not naturally occurring. It is a mixture of minerals. It is solid, but it's not naturally occurring. All right. So that's an important definition. You cannot technically have man-made rocks. We can simulate rocks. we can make rock-like substances all the time. We do it, I mean, constantly, of course. But they're not technically considered rocks because rocks have to be naturally occurring. All right. Minerals. They can have all sorts of different shapes. They can have all sorts of different colors. These are the building blocks of rocks. So I want to draw an analogy here and talk about rocks and minerals and compare them a little bit to molecules and substances. All right. So minerals are the building blocks of rocks. You can think of minerals as being the geologic equivalent of molecules. All right. Rocks are clumps of minerals. In the same way that a pond is a group of molecules and lots of different molecules all mixed together, not just water, but you've got fish, you got all sorts of stuff all swimming around in there. That is your equivalent of a rock. All right. I hope what I'm saying is making sense here. All right. Ground is a whole mix of different substances and molecules all there together. Air, whole bunch of oxygen, nitrogen, carbon dioxide, all swirling about. In the same way, a rock is a mixture of different minerals, and the type of rock you have is defined by the mineral mixture. It's defined by its structure, how it formed, and the minerals it's made out of. All right, let's talk about crystals a little bit. Crystals are defined as regular repeating geometric structures in a mineral. All right, so right here I've got a quartz point, very easily identified as a crystal. So do all crystals need to have a point on them like that? No. Do all crystals need to be glassy and see-through? No. Do all crystals need to be white? Do they all need to have that clarity to them? No, not at all. There are a whole range of crystal shapes and colors. And I've done a whole lot of talking here without showing you a whole lot. So let's go through and have a look at rocks, minerals, and crystals. Enough talk. Let's have a look. All right. So rocks. Right here we've got a graphic granite. All right. I would love to talk about graphic granite in more detail in a later video. It's just an amazing type of rock. I love it. But yeah, as you can see here, visible minerals. You got feldspar in here. You've got quartz running through it also. Regular repeating. But you don't always have to be able to see the minerals. Very often the minerals are absolutely tiny. They're invisible to the naked eye. You can only see them through a high-powered microscope. Sometimes you can only see them through an electron microscope. This here is a phyllite. It's very fine-grained. You will never see individual minerals in that, but take my word for it, it is made out of minerals. Over here we've got a basalt. And we have some pink calcite veins on there. We got some possibly quartz, maybe calcite running through here. It's hard for me to identify that from that. Oh, I see here we got some epidote. So that's definitely a mix of minerals there. And here we have another piece of basalt. This one has mesolite in here, often referred to as Thompsonite in Michigan. So what you're seeing here is basalt, a rock made out of countless microminerals that you can't see with the naked eye. but also pockets of mesolite mineral here, an individual mineral, forming radiating crystals on this. Crystals can occur in all shapes and sizes. Let's go back to those classic quartz points here. You can see beautiful clarity on this piece. I've also got a few pieces I picked up in the Marquette area of Michigan that are lightly dusted with hematite. Really gorgeous look to these. Now here we have another piece of quartz. You can see quartz crystals coming off of it, no doubt. Definitely very clear quartz, as well as some biologics clinging onto this thing. I didn't clean this thing properly. I'm often lazy with my cleaning. But look at most of this. Most of this is very rough. Now, most of this is quartz. In fact, I would say pretty much everything on this is quartz, minus maybe a little of the darker material here. But this is not quartz crystal. All right, at least it doesn't have a well-defined geometric shape to it. All right, so what you see here is the difference between a mineral and crystal. You have quartz mineral all through here, and then you have a crystal coming off. Now, the crystal is made out of the same quartz mineral, but the crystal is that geometric shape. Actually, an even better piece of quartz to talk about crystals and minerals, it would be this one here. This is a piece of vein quartz. You can see most of it is not nice crystal. Most of it is very rough, but it does have crystals running all throughout it. All right. They grew as crystals that just kind of came together and formed a solid mass. But you can see here, mineral quartz, but you wouldn't call this quartz crystal here. If you tried to sell this as a quartz crystal, someone would get really upset with you. But over here, definitely quartz crystals all growing throughout it. There can be lots of different shapes. Don't always look for points. Right here, I have a piece of beautiful prehnite. It's botryoidal. It forms these bubbly textures that the crystals grow off of. Those are crystals. Right here, I have some calcite. Calcite forms rhombic crystals. They also form some points occasionally also, but normally you're looking for rhombs. You're looking for tilted cubes. Very similar to calcite, but different, is dolomite. Dolomite forms actual cubes. I don't believe these are rhombic. I don't believe they're tilted. I'm pretty sure that these are perfectly cubic or very nearly so. Let me go into my drawer here. Pyrite also forms these beautiful cubic crystals on them. Yeah, I get up close to see them sometimes. But again, these are crystals, pyrite crystals. Are they clear? No. Do they look anything like quartz? No. But do they have a regular repeating geometric pattern? Absolutely. How about this guy here? This is botryoidal hematite. Botryoidal comes from the Greek word meaning bunch of grapes, and that is a crystal structure. That is a regular repeating geometric pattern of crystal growth. So absolutely, those are crystals also. Can't see through them, but they are crystals. Here we got a piece of gypsum. This is rhombic also, just like the calcite. Definitely has a different look to it, different hardness. There are different features to this. but it also forms this nice, beautiful rhombohedron. Have a look at this furry guy right here. There's two of them here. Beautiful pieces. They look hairy. Well, that is a crystal form called asbestos. Asbestos is a type of crystal. That's something you don't want to be breathing in. This is the asbestos that used to be used in insulation that got banned. It's very good as a fire retardant, not good for your lungs. It's safe to handle as long as you're not working with it, as long as you're not grinding it up and huffing it. It's fine. So I'm not in danger holding it like this, but you wouldn't catch me grinding it down or cutting slabs of it. All right, so right here we've got some chalcocite. And you can see here this regular repeating structure. I don't believe it's cubic. I can't recall exactly what the structure is, but you can see it is definitely blocky. You can see it's almost like, I love pieces like this because I feel like I don't know, staring into the Matrix or something. It's real interesting to me. I can just gaze into these things and kind of get lost. They're just gorgeous. I love cubic and cubic-like crystal habits. They're just so much fun. You can get needly crystals. Right? I believe these are tourmalines growing in here. But you can get more dramatic examples of that. Let's see here. Over here, we have some manganite here. Manganite has an acicular crystal habit. That is, they're needle-like. They grow from a point outwards, radiating and spreading out as they go. And they're just gorgeous little pieces here. Micas. I love the micas. This is a massive amount of biotite. Biotite mica is black color, and they form these tiny thin plates, and they grow together in masses that are sometimes called books. A book being made of many sheets of mica. Here's another piece right here. I've got a whole baggie right here of muscovite. Muscovite is a transparent mica, and it was actually named after Moscow. A Muscovite is a person who lives in Moscow, because in ancient times they actually used to, in the absence of glass, use large sheets of muscovite for windows in their homes. But you can peel these sheets off. They can be incredibly thin. Here's an oddball. This is native copper. Is it a mineral? Yes, it is. Even though it's just pure copper, it is a mineral. It's naturally occurring and has a well-defined structure, well-defined chemical composition. Copper. Is this a crystal? Yes, it is. Even though the structure to it seems very complex, it is a well-defined structure. It is a crystal. What you have here is a copper crystal. All right, quick interjection here. If you're finding this video helpful or entertaining in the slightest, please like and subscribe. Now, I know you hear that from every single YouTube channel and video you watch, but we're real close to being able to monetize. And if I can even get the smallest bit of revenue, I can justify making more videos like this more often. So please do that. Let's get right back to it. Now, do all minerals have a crystalline form? Technically, yes, and also no. It's a confusing and annoying thing in geology. All right. Some minerals don't form crystals. All right. And those are technically supposed to be called mineraloids. Now we're really nitpicking. Don't even worry about that. But opal is an example. Opal is technically a mineraloid, but it does not form crystals. It's amorphous. Right here, this is a very tiny piece, but very pretty. Chrysocolla never ever forms crystals, always forms masses. It is technically a mineraloid, not a mineral, but again, we're really nitpicking there. And as we've seen, not all minerals have to occur in crystalline form. Right here, we've got some beautiful sodalite growing on this piece. And you wouldn't call that a sodalite crystal, but there's definitely mineral sodalite all running through it. Now, my table's getting real messy, so before it's completely cluttered, let's talk about a couple of remaining words: gemstones and jewels. How are those different from crystals? Well, now we're talking about how desirable they are. All right. A gemstone is a highly desirable rock. It's defined as being a semi-precious or precious rock or crystal. All right. And a jewel is a precious gemstone. That is a highly, highly desirable, almost always crystalline stone of some sort. So, quartz, beautiful crystals. Are they gemstones? They are not generally considered gemstones because they're not valuable enough to be considered gemstones. Over here, I have a collection of beryl crystals. These are not gemstones, but if they had better clarity to them, their price would increase. They would become much more desirable for jewelry, and they'd be called emerald. And that would make them not just gemstones, that would make them jewels if they were full-on emeralds. However, these guys don't have the clarity required for that. I think most of these guys would probably be classified more as aquamarine. Maybe a gemstone, maybe an almost gemstone. Definitely not a jewel. The state gemstone of Michigan is Isle Royal Greenstone. I've got some right here. You can see here, it's not transparent. It's not gemmy. It's not a jewel by any means. It's not valuable enough to be considered a jewel. But it is considered a semi-precious gemstone. Why? Only because it is highly desirable and extremely rare. If it was real common, not a gemstone. You just call it a mineral or a crystal, but not a gemstone. Gemstones and jewels are defined by how rare and valuable they are. Right here, I've got a whole baggie full of beautiful pink tourmaline crystals I collected. I collected these as a child in Southern California. These are considered gemstones. Why? Because they are semi-precious, they're desirable, they're rare, you don't find them everywhere, and they're beautiful. People spend money on them, and so that makes them a gemstone. Are these jewels? Well, is it a jewel? Well, how much are you willing to pay me for it? These, I think, by almost every standard would not be considered jewels, but they would be considered gemstones. Right here was the best piece of tourmaline I ever collected as a child. And you see a whole mix of things. This is a big piece of rock here. You have mica crystals coming out of the rock all over here. We've got a quartz point coming out right here, and we've got tourmaline coming out right here. So what are we seeing? We're seeing rock, we're seeing minerals, we're seeing crystals, we're seeing some semi-precious gemstone here. Now, am I going to show you a jewel today? I am not. Why? Because I am not rich. I don't. I don't collect jewels. You're going to have to go to somebody else's YouTube channel if you want to see a big collection of jewels, or wait for me to walk through a museum and film. But I hope you've learned a little bit today. All right. What is a rock? A rock is a collection of naturally occurring minerals. All right. A naturally occurring collection of minerals. All right. You can't make a man-made rock because it's not technically a rock anymore. Crystal is a regular geometric pattern occurring in your minerals. The minerals are the building blocks of rocks with regular or somewhat regular repeating chemical compositions. All right. We talk about cobbles, boulders, pebbles, gravel. That's all based on the size of the rock. And whether it's a rock or a stone just depends on what part of the world you're from, what your favorite word is. All right, well, I hope you found this real helpful. You've got a lot more information now than you did about 15 minutes ago. Keep it in your pocket, whip it out on trivia night, educate your friends and family in a helpful way, never snobby. And use it to educate and inform your own rock hounding, your own fun out there. Now get out there, have some fun, collect some cool stuff. I hope to see you back here again real soon.